We are going through exercise 6C, and in this video, we're going through question 1G, which says, without dividing, find the remainder when the first polynomial is divided by the second. So that means we are taking our first polynomial and we are dividing it by the second one. So that means my first polynomial is my dividend represented by p of x, and my second polynomial is my divisor represented by d of x. In order to find my remainder, I'm going to be using my remainder theorem, which tells me that I take d of x and I set it equal to 0. So that means I'm going to get 2 of x plus 3 equals 0. Then I'm going to solve it for x. So that means x is going to be equal to negative 3 on 2. Now what I do is I take this and I substitute it into my dividend, p of x. So therefore, p of negative 3 on 2 is the remainder. So that right there is all the conceptual stuff behind the question. If you can do this, I would argue that you can do the tricky stuff. Everything that follows now is simple arithmetic. So let's now do it. So that means what I'm going to do now to find what my remainder is, the number itself, I'm going to sub this into this. So it's going to be p of negative 3 on 2 is going to be equal to, every time I see an x, I'm going to put negative 3 on 2. So it's going to be 6 minus 5, negative 3 on 2, plus 9, negative 3 on 2 squared, plus 10, negative 3 on 2 cubed. All right, this is not going to be nice. This is going to be a disgusting question. Someone should be fired at Cambridge for this. All right, let's go. So we're going to go 6. Now I've got 2 negatives, so it's going to become a positive. And then I'm going to go 5 times my numerator, which is going to be 15 over 2. So my denominator doesn't change. So 5 times 3 is 15. Let me continue, plus 9. Then what I'm going to do here is I'm going to square this. My negative is going to go away. It's going to be square root of 3 is 9. Square root of 2 is 4. So remember, you're squaring both the numerator and the denominator. Then we're going to plus 10. Now, I am now cubing a negative number, meaning it will remain negative. I am going to cube the top. 3 cubed is 27. Then I'm going to cube the bottom. 2 cubed is 8. Perfect. Let's now continue. I now need some common denominators. So this is fraction work now. So I want this to have a denominator of 2. That means I'm going to times the top and bottom by 2. So it's going to become 12 over 2, which is 6, meaning I haven't changed anything. I've just made it a common denominator with my next one, 15 over 2. Then I'm going to continue plus, now I'm going to go 9 times 9 is 81 over 4, negative, so remember you got a negative here, so it's going to become negative 10 times 27 is 270 over 8, which is going to be equal to, when I plus these together, I'm going to get 12 plus 15 is 27 over 2 plus 81 over 4 minus 270 over 8. Now, there's probably more than one way to do this, but when I look at this, I can see that I should make all of these have a denominator of 4. So if I times my top and bottom by 2 here, I'm going to get 27 times 2 is 54. 2 times 2 is 4. Plus 81 over 4 minus, I'm now going to divide my top and bottom by 2. And that means I'm going to get a 4 down here. I'm going to get 270 divided by 2 is 135. Then I'm going to move on to the next one. Now I just have to join these together. 54 plus 81 is going to be, oh, you're joking, it's 135 over 4 minus 135 over 4, which means it's going to be 0. You've got to be joking. So that is 0, meaning p of negative 3 on 2 is 0. Your remainder is 0, which means that if we go all the way back here, 2x plus 3 went perfectly into my polynomial. That's really cruel of Cambridge to do to us, but it now leads us nicely into our next topic. Well, not next topic, but our next idea. So we've talked about the remainder theorem. Next, we're going to be talking about the factor theorem, which means when your divisor goes perfectly into your dividend, you know that it's a factor. But we'll get into that later. Hopefully this video has been helpful to you and it didn't annoy you as it annoyed me.